Hello everyone, welcome to my channel Coding Together. My name is Vikas Oza. Today we will see another Leetcode problem, that is element trie, or also called prefix trie. So it's a medium level question and it's a very popular question, as you can see from the likes. So let's read the problem statement. A trie pronounced as trie or a prefix tree is a tree data structure used to efficiently store and retrieve keys in a data set of strings. So there are various applications of this data structure such as autocomplete and spell checker. So we have to implement a trie class with a constructor trie with a method insert that takes the word and inserts the word into the trie. There is a search method that takes the string as word and returns true if the string word is in the trie or IE was inserted before, and false otherwise. The last method is starts with, which takes the string as prefix and returns true if there is a previously inserted string word that has the prefix or and false otherwise. Let's see some properties of the trie. So trie, as stated, is a rooted tree, and with each node of the tree has two properties. First, each node has R links, you can say, right, has R links, where R is equal to 26, which corresponds to the 26th character of the string data set or the string alphabets. And also there is a is end boolean variable associated with the node that represents whether this node represents the end of the key or not, right? So there are some operations that we can see. First, the two main operations is insert and search prefix. The three main operations, and these three main operations also need some auxiliary operations, that is put, get, and contains key. So put is to create a link between the parent and the child node. Get is to get the link between the child and the parent node for a particular character, and contains key that returns the boolean whether there is a link for a particular alphabet or not, right? So let's see, if I do put ch and the trie node, it will add a link for a particular character, suppose A, right? It will add the link for a particular character, and it will link that node with the parent for that corresponding link, right? And get ch will return the link or the node, trie node, for that particular character, and contains key will check whether there is a trie node present for that character or not. See the first operation, that is insert. So let's insert two words, that is leet and code. So we'll start, so these are our two keys, so we'll go character by character. So first we'll start with the root node. So root node has 26 links, right, corresponding to each character. So at the start there is no child node for the character L, right? So we will add a link for the character L, and we'll add a child node to the parent node. Then again we'll check the letter E. So for this, from this child node there is no link present for the character E, so we'll add a link E, and we'll add a child node from this node. Again we will add, then for the corresponding for the next letter E, we'll add a child node, and again for the next letter T we'll add a child node, and we'll mark this child node or the leaf node as is end equal to true. So this represents that this is the last character of the key leet, right? This is the last character of the key leet, right? Now we will add code. So starting with the root node, there is no link present for the character C, so we'll add a new child node and we'll link it with the parent for the character C, right? Now again from the C there is no link for the character O, so we will add a new node and we'll link it to the parent's link matching the character O, right? Again we'll add a new node that matches the parent's link corresponding to character D, and from the D, as there is no link present for the character E, so we'll add a node and we'll add the link corresponding to the parent's link matching character E, right? And we'll mark this node as is end equal to true, that represent this is the last character of the key code. In this trie data structure, we'll search now the word leet. So we'll check from the starting from the root node, is there any link corresponding to the letter L? Yes, there is a letter, so we'll move down to the child node or the next node, and then we'll search the link for the character E. So there is a link for the character E, so we'll move down to the next node. Then again at the next node we'll search the link for the character E. So there is a node for the character E, right? So we'll move down to the next node, we'll search for the character T. Is there any link? Yes, there is a link for the character T, so we'll move down to the next node. Now we have out of the keys, right? So we'll check whether this node is end is equal to true. So yes, is end equal to true, so this whole word is present in the trie, right? So it's present in the trie data structure, right? So we'll iterate and we have to check is end equal to true, right? Both. Now we will check for the prefix, right? So now let's suppose we see LE, whether LE is present, right? We'll search LE, not search prefix, but we'll search LE, whether LE as a word is present in this data structure or not. So we'll start from the root node, we'll see the link corresponding, we'll check the link corresponding to the letter L. So yes, there is a link present from the node, so we'll move down to the next node, we'll search for E. Yes, from this node we have a link present for corresponding to character E, so we'll move down to the next node. But at this node, because we are out of the characters, so but at this node, is end is equal to false. So this means that LE is not present as a word. But if we want to search LE as a prefix, right? So if we perform search prefix LE, then it will be return true, because at this node we will not check is end equal to true, right? So because for this at this node is end is equal to false, then it means that LE is a prefix for a word already stored in the data structure, that is leet, right? So if we do search LE, then it will return false. But if we do search prefix LE, then it will return true, depending upon this is end flag. So because is end is false at this node, so it means this is not a word stored in the data structure, but it is a prefix. Let's see the Java code for it. So we have created a public class trie, which has a inner class that is trie node. So each node, this represents the node of the tree, which with each node as R links and a boolean variable is end that represents that this is the last character of the key. And we have initialize links with the R sized trie node array. Now three main auxiliary functions, that is contains key, which tells us that there is a link for a corresponding character ch in that node or not. Get method that returns the link for that particular character ch, and put that adds a link for that character ch into the node, into the parent node. Set ends marks the node as a end character for a key, and is end gives us the boolean value of whether that node is a end character of the key or not. So in the constructor we will initialize our trie node, and in the insert method we'll start from the root node, we'll iterate each character of the word, we'll first fetch the character into the char variable, and we'll check whether there is a link present for that current character in the root node or not, or in the current node or not. If that is not present, we'll add a node corresponding to that character, we'll add a link corresponding to that character in the node, and we'll get the node that we added for that current character, and we'll perform this operation till we are done with the each character of the word, and finally we'll mark the last node as the end. For the search and starts with, we'll call this one main same function, that is search prefix. So what search prefix does is, we'll start with from the root, and we'll again iterate each character of the word. We'll take each character of the word and we'll check whether the node contains a link for that character. If yes, we'll move down from that node to the child node, right? So we'll return null. And if we have iterated over the complete word length, we'll return the last node. So in the search method, we'll perform the search prefix and we'll get the last node. So either node can be null or not null. So if the node is not null, so it means the complete word is already inserted before in the trie. And if node is end is true, right? So for search, the complete word has to be inserted, the complete word has to be present. So that is specified by the isEnd variable, isEnd boolean variable. So if the node is not equal to null and the node.isEnd is equal to true, it means that the complete word is present in the trie. Now for the starts with, it means that we have to only search for the prefix. So when we perform search prefix and we get the node, we only check node not equal to null. We don't check node is end, because it doesn't matter whether it's the is end for that node is true or false, because we only want to search as a prefix. Now let's run the solution. So yeah, test cases are accepted, so means the solution is working fine. So let's see the time complexity of largely two main functions, that is insert. For the insert, we are creating the nodes which is equal to the length of the key, right? The length of the word. So the time complexity will be big O of n, where n is the length of the word, is the length of the word that we want to insert, right? And for the space complexity, as we are maintaining we are creating n nodes, where n is the length of the word, so the space complexity of b will be big O of n. And for the search prefix, right, the first prefix, again the time complexity will be big O of n, because we are searching n nodes, where n is the length of the word. So we have to iterate n times, so n nodes, right, to search for the complete word. And the space complexity will be order of, or the big O of 1, because there is no node we are creating, so that's why it will be big O of 1. So I hope you like this video. If you like this video, please share and subscribe. Thanks for watching. Bye.